Hello, good people of DSSD. Today I'm going to be talking about electric fields. Electric fields are really cool because they allow us to figure out how charges will interact with each other and how those forces will affect other charges. So, let's get started with the hypothetical. Let's imagine we have a positively charged object, right? In your module today, you learned that that positively charged object could be a proton or it could be a sweater that we took all the electrons off of, right? And let's imagine we bring another positively charged object near it, right? Let's say we've got a couple different little smaller positively charged objects all around here. Now in electric field, you just draw how this one big positive object would affect all the little objects, right? And so for these ones, if we have two positives next to each other, this one would be pushed away, right? This one would be pushed away. This one would be pushed away, and then this one would be pushed away. And so that brings us to our first rule of electric fields, is that the arrow should be in the direction of the force that would act on a positive test charge. So you always imagine that these little tiny charges we're putting around our one big charge are a positive. So moving forward, imagine we had a negatively charged object, right? We've got this big object in here, right? Maybe it's our balloon after it took all those electrons. And so instead of pushing a positive away, imagine we have this little tiny test charge right here. What would this little tiny test charge want to do? That's right, it'd be sucked straight into here, right? And so instead we draw fields that look like this, where we have all these different objects all these field lines going directly toward our negative object. Awesome. So that brings us to our second rule. Arrows always point away from positive charges like we saw and towards negative charges. So we've talked about what happens if we have one simple charge. What if we have multiple charges, right? What if we had two objects? So let's say we had a positive charge and a negative charge, right? So we know arrows are going to move away from our positive charge, right? So we'll start out like this, drawing an arrow like that, and toward our negative charge. And so when you have two objects like this, what you can do is you can actually connect these two points right here, right? Because we know if we have a little positive test charge right here, like let's say we put a little positive test charge, it'll want to move away from that bigger positive charge to the negative one. And so we can draw all of our field lines like this till eventually they start forming this kind of cool, I don't know if you could call it like a donut shape or a solenoid, and then these point out like this, right? And these charges, you can't see them, but they point in like this. Cool. So that's what happens if we have a positive charge and a negative charge. Well, and what if we have two objects, right? Like let's say we have two positive objects. We know that on the other side, things are going to be moving away from these positive charges right here. But what happens in between them, right? What happens if you're a little proton stuck between these two right here? What happens if you start right here? Well, what actually happens is you get pushed upward and outward, so you're not stuck between these two giant charges. And so what happens is the field lines look like this, where they actually get shoved upward and sideways. So that's what our charges look like if we have two positive charges. So for all of our rules, the arrow should always show the direction of the force that would act on a positive charge. These don't work if you use a negative charge. So whenever you imagine those little charges I was talking about, always make sure they're positive. Arrows should always point away from positive charges and toward negative charges, right? And so when we have a positive piece, we'll have those arrows going out. When we have the negative piece, we'll have them pointing in. Opposite charges connect with arrows. We saw that like this. You can see that they're connected by arrows, whereas similar charges point away from each other. So like this. And if we have two negative charges, the same thing would happen. They would still be bowed out from each other. So arrows should fill the space and show the field in all directions to the edge of the box shown. So after you watch this video, what I want you to do is go to the next slide and open up this little PhET sim right here that we have. And so if you guys go to this PhET sim right here and you click on showing the field, so make sure this little box is checked, what you can do is you can drop a positive charge and it'll show you what those field lines look like. And so right next to the charge, it's really strong, right? Because the force is really strong right next to our charge because it's inversely proportional to the distance. And if we run this little simulation, right, we can see that this pushes our little positive test charge away, right? And so we can always look at these field lines and we can take these two together. You can see that it looks exactly like what we think we'd look. And so you guys can select different difficulties right here to test out, okay, I'm going to hit clear all, to test out how to get this positive charge into this goal right here. And so try experimenting, try using a bunch of different charges to see what you can do to push this puck around to get it to work. All right, thank you for watching. Best of luck to you all. See you again next time.